Alright, welcome to the 7th lecture. We will be continuing with the grasp patterns today and continue the implementation and design of our blackjack game. My hope is to manage to go through all the grasp patterns this week, so you are at least have a good foundation for designing the second workshop. However, first of all, I would like to inform you that the suggested solution for the first workshop is online on the course homepage, so you can take a look at it. This is my idea of how to model the domain of the Happy Pirate. Quite bare-boned. Many of you have some more concepts here, maybe. Some of you may also have slightly different associations and so on. But overall, I think, sorry about that. But overall, I think most of you had managed to capture concepts like member, boat, birth, calendar, or calendar event, or something like that. Many of you also got kind of like entangled in the authentication part. As far as I'm concerned, this has nothing to do at all with boat clubs. So adding a lot of roles and logins and passwords and stuff like that, it's clearly software. A necessity for us to make this a software system rather than a boat club. You should be able to see that page if you log in. Logged in and registered. That's kind of weird. I will take a look at it then, later on. Anyway, I will check the permissions during the break so that you can see it. But anyway, you have the model here, quite bare-boned, and you have my little discussion about different parts of it here. Most of you will pass the workshop. I will start sending emails today. Some of you will have to make a small, some small extra assignment, and that assignment will just be to take a look at this suggested solution, take a look at your own model, and then write a small text about why your model differs from this one. What mistakes did you actually make? But those groups I will be contacting with further instructions. So you can take a look at it later on then when I fix the permissions. And we could also discuss possible questions on Friday, the lecture on Friday maybe. So feel free to take a look, compare with your own model, and ask questions on Friday or in Slack. That said, we started with grasp patterns yesterday. We did this blackjack game, but we did not really talk about grasp. So grasp is general responsibility assignment software patterns. So you have possibly been hearing me talking about responsibility. Where should we put this responsibility? Who should be doing this in the system? And this is a method of designing object-oriented systems that's called responsibility-driven design. So you think about tasks to be performed in the system in terms of responsibilities, and then you distribute these responsibilities to different parts of the system, down to the classes and the operations that are supposed to implement them. And responsibility can be in two ways. You can have the responsibility to know something, who needs to know this? In essence, this becomes attributes. So where should we put the color and the value of the cards? Well, probably in the card class. That's a good idea to have this knowledge in the card. And we can have responsibility for doing things. And this responsibility at the lowest level is fulfilled by a function, an operation or of some sort in different classes. Or it could, at a higher level, be a subsystem that performs something, or a collection of classes to perform a responsibility, doing something. In our case, we could take a look at this shuffling operation. Okay, the cards needs to be shuffled. Where should we put that responsibility? So this is the general idea of these patterns, to give you some guidelines and rules on where to put things. What part of our system should be responsible for this? Well, okay, we have these kind of like rules for this, and we could try to apply them to find a good design. And of course, you have the domain model as an inspiration when doing this. So you don't kind of like throw the domain model away, but you look at the domain model, find inspiration there, and the design we did yesterday was very inspired by the domain model. We had the same class names, and we could see that, well, a card has a color and a value, so we should probably put these attributes in the card class in the design also. It's not always the case that you can make this direct transformation, but it's a good idea to try. So responsibility-driven design. And we have a number of patterns here to take a look at. Do you remember what a software pattern is? A named, abstract, problem, and solution. So they have a name, they have a problem to solve on an abstract level, and they have an abstract solution. And your job as a designer is to recognize, okay, what is my problem, my specific problem, what types of abstract problems does it fit into, which one should I select, take a look at the abstract solution, and apply it in your specific case. And the patterns are information expert, creator, controller, low coupling, high cohesion, indirection, polymorphism, protected variations, and pure fabrication. So these are the basic grasp patterns that we will be talking about. And we talked about creator yesterday. A lot of stuff was to be created in our blackjack game to have something to start with. So we talked about the creator pattern. And actually we used another pattern here also. So this shuffling operation, it kind of like just got thrown in there without much thought, I think. So we should take a look at that again. So for some reason, we saw in the requirements that, okay, we need to shuffle the deck, or the dealer shuffles the deck. He takes out a new deck, he shuffles it, so that the distribution of cards is kind of like random. And we added this responsibility to the deck class here. So we did this little operation. I think I will just make it a little bit bigger. Why did we add it there? Why did we add the responsibility to shuffle the deck into the deck class? We could have put it in the dealer. In reality, actually, the dealer probably takes a card from the deck and puts it on top. Self-shuffling decks are not that common in reality. Would be really neat though, but it's not that common. So why didn't we put this responsibility into the dealer? We could have just added an operation here, get random card. Put this loop outside and in the dealer instead. Let's do that and just see what happens. So something like this then. Can't do static like that maybe. Oh well. So some quick coding, return the card, and outside in the dealer we will be doing a little bit of this also. So something like that maybe. Yeah, not much to show, but okay, you understand what I did? Added the method to get a random card to the deck instead, and then just move this shuffling loop out to the dealer, which is maybe the way it works in reality, that okay, I pick a card from the deck randomly and I put it on top, and I do that kind of like 1,000 times, then it could be considered shuffled. So why did we add it to the dealer, to the deck class to begin with? Which solution is better? We had this one, or we had this one. Any ideas? None? Yeah, in the chat here, one point is that dealer now becomes dependent on the card. It uses the card here, so we get a dependency from dealer to a card. So we have added a dependency, and that is always not a good thing. However, I think that in the course of things, I think that dealer must handle cards in some way. So while it's indeed a point right now, I think that that dependency cannot be avoided in the future anyway. So it was good of you to spot it, but I think that we could argue that we will be adding this card dependency as we go along with the design, most likely. And I should know because I have done this game a few times now. So there is absolutely a point. Don't add dependencies if you don't need to. But there is another principle that we could take a look at, and we could actually look at the code. This operation kind of like just calls the deck, gets something from the deck, and then adds it to the deck. And the code kind of like tells us that, well, maybe why not put all of this into the deck instead of making all these calls. You make a lot of calls, so if you have the situation where you call something in another type and you kind of like do something with that stuff, maybe that responsibility should be moved into this type instead, this class instead. And also, you could think about, okay, what do we need to fulfill this responsibility? Well, we need the cards. We need access to the cards. That is what we need. The information that we need is access to the cards, to shuffle them. And we could take a look at, is there anyone that has the access to the cards already? Yes, the deck has access to the cards. And this also ties into this dependency stuff. So you should always try to figure out, when you face a responsibility, you should think about what information is needed to fulfill this responsibility. In this case, it was maybe so obvious, so we did not really think about it, at least not yesterday. So we need access to the cards, we need to put them into the deck, and well, the deck already has access to the cards. So in this case, this is not really a good solution. So let's revert it. And this is maybe the first principle in GRASP, and sometimes it's so obvious that you don't think about it, but in my experience, when you run into problems in your design, it's because you have violated this, this first pattern in many cases. And that is the information expert pattern. Here we have the presentation. So it's the first pattern that we have in the list. And the problem is, what class should get a specific responsibility of knowing or doing something? And we should assign the responsibility to the class that has the information needed. And in this case, well, the information needed was the cards, and we put the responsibility into the deck because it had the cards that were in the deck. And this is can be quite hard. Can be hard to know what is actually needed, what information do we need, and really think about what is needed. And there may also be other forces in play here, like architectural constraints. For example, if you remember back to our little circle example, where we did this, okay, we did a math application and we had a circle class, and well, it had a radius and some operation on that radius, and then we put, well, it needs to be rendered also, and what information do we need to render it? Well, we need the radius. So let's put this responsibility into the circle class. And well, it became bloated and not so good because we violated the model view separation principle. So sometimes you have different different motivations and different factors that influence your choices also. And this is something to think about when designing. So always go back to information expert if you are unsure. Always think about, okay, what information do we need to fulfill this requirement? To find at least a good candidate for your design. And this is maybe something that you do already, more or less automatically, but sometimes you run into problems, and always take a step back in those cases and take a look at this pattern. We did the creator yesterday also, as we created a lot of objects, deck and card and stuff like that. So here we have some rules for this, and we absolutely saw that we had the containment of objects in the deck and the card, and we could probably see that the dealer will be handling the deck. So, well, maybe it's a good idea to create the deck inside the dealer. And we have some other rules here also, especially the second rule here, the information needed to create A objects. Could be said to be, this is the kind of like the information expert when it comes to creating stuff. So if I have the information needed to create objects, then maybe I should be the one who do it. In this case, we needed to know what cards we had in the deck before we created them, so we did not create duplicates. And we could argue that, well, the deck should create the cards not only because it contains the objects, but also as it knows what objects have been put in the deck already. So it could be perfectly fine to let the dealer object create the cards and add them to the deck. So as you see, we have a lot of different, we can solve functionality and problems in a lot of different ways. And these will give us different qualities. It will affect how easy our system is to understand, how easy it is to maintain, how easy it is to reuse parts of it, how changes will propagate. If I change in one place, will I have to change everything else? How easy it is to add new features. So by thinking about these patterns and about the options that we have, we can find good designs. So let's go back to the code, I think. As you may remember, we kind of like did something in the model here with the cards and the dealers and the deck, and we also added a console view to present this new message. And maybe we should take on the third requirement, and that is that you should actually be able to quit the application. And this will also actually let us exercise our whole architecture, so to speak, because right now it's kind of like just, well, I created a dealer here, and then I created a view, and then I presented the instruction, and we're done. And it's not really an application. So you probably remember how to do this from the dice game. So we have this event of the user wanting to quit, and who should take on that responsibility. If you remember back to our little dice game, you probably remember it's not a good idea to return low-level input from the view. So we should have this kind of like event of quitting, and just add that. And who should receive this event? Well, a controller should receive it, as stated in the chat here. So let's add a controller. I will be calling this player. This is very similar to could do it maybe like this. Let's let the controller be the one that prints the welcome message also. Something like that, and I think we should just add a clear screen here. So every time we input something, it just gets rewritten, and if we press Q, we quit. So 2 requirements out of 3 done. And we added this into a controller. Controller kind of like orchestrates how things should happen. Presents the instructions and then returns false if the player wants to quit. And then out here in the program we have a loop construct, so if the player wants to continue to play, well, you just get a new call here. Have some question in the chat, maybe? I can show player again. I can make it a little bit bigger also for you to see. Yes, the controller now has a dependency to the view. This is quite common in model view controller, and especially as we were doing the at least we'll try to do the now I forgot the name. Not the passive view, but the supervising controller variant of the MVC, the controller class will definitely have much to do with the view and have much to do with the model classes. And this is one of the problems in this variant, that, well, the controller classes are very hard to reuse. They become sensitive to changes. If you change something in the model, well, the chances are that you need to change in the controller. The upside is that the view classes are not that sensitive, and of course the model classes are not that sensitive to changes in controller or view. And we will probably need to change this code as we go along with the design here, so we will see what happens. All right, and this brings us to the next pattern that is called controller. What class should handle system events? And this is typically, a system event is typically not a mouse press or a key down or something like that, but rather events at a higher level. In our case, it was quite simple because we had this wants to quit event, and we tried to make this as high level as possible, but in the view it's, well, he pressed the Q key. But then we generate an event from this, and we ask the view, well, what has happened, or does the user wants to quit? And in the view it could be voice command or whatnot to check this. So typically in a web-based system, well, you have filled in the form and pressed submit. That's a system event. Something bigger than something small, so to speak. And we should assign the responsibility to a class, often called controller then in some way, that could represent the system as a whole. This is called a facade controller, good for small systems where you don't have a lot of interaction. The problem here could be, of course, that, well, you have a lot of system events and a lot of different things that could happen, and this one whole class could become quite bloated. So we have other options to handle system events in classes that represent a role, a use case, or a scenario, or a session, or an input device. In our case, I opted to use the role, the player, as the name of this controller class, and the operation is like, well, maybe the use case for playing the game. So I call that play game. And this provides a good mapping, I think, from requirements, actors, requirements, use cases, into the design and implementation of things. And that is always a good idea, because it makes it easier to find stuff. When things go wrong, you know, okay, who was logged in? Well, it was an administrator. Maybe I should look in the administrator class first and then find what he wanted to do. He wanted to add a user. Well, find the add user operation and start there. So, let's move on. We have maybe taken on two quite simple requirements so far. If you remember, the big requirement is like play the game. But we can at least start the game, get the instructions, and we can quit the game. And to start a new round, this is the first step, really. And I think it's 2A, if I'm not mistaken from here. 2 and step A here, so we have some more details here. And the way that this turns out is that the dealer should take the top card from the deck, should show it, and give it to the player. The next step is that the dealer should take the top card of the deck, show it, and give it to himself. The dealer should take the top card from the deck, show it, and give it to the player. The dealer takes the top card from the deck and gives it to himself. And this time the card remains hidden. So after this is done, the player should have 2 open cards. The dealer should have 1 open card and 1 hidden card. And finally, we should present the scores of the dealer and player hands so that we know the amount of points each hand has. So, how should we start with this design then? Well, let's do it by the book and start with a sequence diagram. That is probably the easiest part. And we have like a recipe for how to do things here. So I will be at least trying to use a web service called Web Sequence Diagrams. It's quite good, not perfect UML notation, and especially these create messages are not supported really. So that's why I didn't use it yesterday. So, but when you have these tools, you always have to kind of like think about what do I need to show really and how. So let's start from the beginning, I think. And we could take a look at our code and, well, the program class calls the controller, and that was named player. I will add this little notation here if it allows me at least. Yeah, C for controller.player, so they know that this is inside the controller. And play game was the operation. And this one should probably ask the view. We could probably send in the view there, because that we know about. And as we are doing this specific scenario of starting a new round, we could, we don't need to display every option available. So we don't need to go through the, well, oh, maybe the user quit first. So in a sequence diagram, you can opt for a specific scenario, and in this case, well, we're doing the scenario of the startup of a new game round. So this we could focus on. Otherwise, sequence diagrams kind of like become very, very cluttered. So what should happen here? Well, the player should probably ask the view. If the player wants to start a new game. And in this case, we can just say that, yes, he wants to do that. And what should happen next then? Well, we can take a look at our requirements and see, well, we should probably tell someone that, okay, now something in the model needs to be notified that, well, the player wants to start a new round. And who should get that responsibility? What information is needed? Well, you need to handle the cards, so you need information about the deck and the cards, and something called player here also. So let's start with who has information about the deck and the cards. What did you say? The dealer, exactly. So the dealer already has the deck. So the first step is probably to tell the dealer that, okay, the player wants to start a new round now. Do your stuff. So we will be delegating this whole mess to the dealer. And what should the dealer do then? Well, it should get a card from the deck. And this is not possible to do then. Something like that. He should show that card. And he should give it to the player. So, okay, the player, what is that right now? We have a concept called the player inside the controller. What would happen if we call stuff from the dealer that is inside the model into something that is inside the controller? That would violate the separation principle. We can't have dependencies from the model into something in the view or the controller. So, okay, what should we do now? Yeah, and the answer here is, well, we should add a class inside the model that is called player. And this is actually quite interesting because we have both a role of being the player, the outside player, so to speak, and that is the controller part of our system, the controller player. But we also have this, well, we need to store the hand of the player, and the player needs to have cards and points and scores and stuff like that, and that is part of the domain. So we have this concept of a player inside both these packages. So we should probably add a model player also. And we should give him the card deal, maybe? Card? Yeah, let's name it that. So after this is done, we should kind of like do the same thing, but instead of giving it to the player, we should give it to myself, and then I should give another card to the player in the same way. And finally, I should give myself a new card, but I should not show it, so let's not call it show. So something like that, I think. So from the program, play game is called on the controller player. The controller player asks the view if the user wants to start a new game, and yes, he wants to in this scenario. And then we call the dealer and tell him to start a new round. And the dealer gets cards. He shows cards and deals cards to the player. A new class in the model. And he gets card and he shows card and deals it to himself. Get card, show card, deal card to the player. Get card, deal card to himself, and does not show it here. So we have basically taken the requirement, broken it down, and made a quite detailed design on how to implement this. And during the break, you can think about how the class diagram will look, and we will start implementing. Questions? Good. As you see, this is not perfect UML notation. I think you can even switch to other stuff here. Let's not do that right now. But it is not perfect, but it is sufficient for our needs. One thing we haven't done here that we maybe should add is, we need to calculate results and stuff like that also, and show the cards and bits like that. So we will continue with that also. But you can think a little bit about the class diagram, what will happen during the break. So 15 minutes of a break.